Before we get to the implementation of the interrupts architecture in 8085, I wanted to talk about the SIM and RIM instruction. SIM in 8085 means that if we have 00110000 in binary or 13 hex in the IR register, then the CPU would do this. It looks at the A register. It first looks at the bit number 3 or the fourth bit from right. If it is 0, it would ignore the bits number 0, 1, and 2 in the A register. Wouldn't do anything. If it is equal to 1, then it would look at the first 3 bits. Any one of these bits is equal to 1, it would mask or disable the corresponding pin in the RSC 7.5, 6.5, or 5.5. Like imagine we have executed the SIM instruction. By this, we mean that currently in the CPU in IR register, we have the value of 00110000. What the CPU does is that it looks at this bit. Let's say it is equal to 1, 7.5 is equal to 1, we have 0, and we have 1 here. Now, what the CPU would do is that it says, well, this bit is related to 6.5, these two are related to 5.5 and 7.5. Because this one is equal to 1 and these two are also equal to 1, it means that the programmer that has executed the SIM instruction wants these two pins to be masked or disabled. In other words, from now on, the CPU would ignore any changes at the pin number 9 and number 7, which are interrupts which we call RST 5.5 and RST 7.5. If you want to mask all of them, obviously you see 1, 1, 1, 1. It means if you want to mask all the RST 5.5, 6.5, and 7.5 using SIM instruction, while you want the INTR to be enabled, so you have executed the EI instruction, which is for enable interrupts, but here you say 1, 1, 1, 1, which in hex would be F. So you write in the A register the value of anything and F. This would mean that mask all the pins of 5.5, 6.5, and 7.5. Now, in the next lecture, we explain how these pins go in the architecture that would cause those interrupts to get actually not realized by the CPU or ineffective at all. The other 4 pins are for this. 7.5, again, reset would be explained in the next lecture as part of the architecture. This pin wouldn't have any effect. You see, these are the A register. If you want to execute the SIM instruction, first you put some value in the A, just related to what you want to be done. When you say SIM instruction, remember, when you put this value in the IR register as the programmer, the CPU would instantly look at the A register and would interpret the incidents or the bits just as we are explaining here. About the serial data, you see, when you are communicating in the 8085, we have 16 pins, as we said, which are for the address, and 8 of them are for multiplex between data and addresses, which we show them as A0 to A7. So at each time, 8 bits are actually transferred or communicated with other devices. We could communicate 1 bit at a time using a method which is called serial data communication. The way that it works is like this. If this pin is equal to 1, whatever this pin is, the CPU would put it on the pin number 4 as serial out data. And the RIM instruction, so you see, these SIM and RIM are called multi-purpose instructions. The way that RIM works, it's the opposite of SIM. You want to understand what is going on. So if you put the value of 00100000 or 20 in hexadecimal, Then after the execution of this, you could read the value of a register, and you could analyze them as follows. SID is dev bit at the pin number 5. So let's see, you have put the 8085 microprocessor on a board and with some other devices, and you have executed the RIM instruction. Right now, if you execute the RIM instruction and read the values, read the A register, then the last bit or the most significant bit would tell you what is the value at the pin number 5. So the other ones are like this. IE tells you whether the interrupt flip-flop is enabled or not, which, as I said, is part of the architecture of interrupts. But if you say EI, enable interrupts, we said the enables would be enabled, and DI, it would disable it. So this pin says whether the interrupts are disabled or enabled. 5.5, 6.5, and 7.5 would tell you whether these pins, these bits, whether these interrupts are masked or not. So whatever you did in the sim would be shown here. Like if you masked them previously as 1, 1, 1, then they would have the value of 1, 1, 1. Then we get to these 3 pins, and these 3 pins tell you if each one of the pins, the interrupts are pending or not. We said sometimes different interrupts are getting activated at the same time, but depending on the priority, some of them, well, they would get executed one after the other, and you could understand right now which one of them is actually pending that would get serviced later. So this was a summary of the sim and RIM instructions. In the next lecture, we get to the architecture, or the way that all of these interrupts are actually implemented, which would give you a more intuitive way of comprehending interrupts.